graph shows the energy profile for a chemical reaction. We have two energy profiles. We have the endothermic and exothermic reaction. Are we following? So for exothermic reaction, enthalpy change is negative. What did I say? Enthalpy change is negative, while for an endothermic reaction, enthalpy is positive. Are we following? Now we have the reactant side and we have the product side. For an exothermic reaction, you notice that the reactant side is higher compared to product side. A kind of reaction in which it is giving out to the surroundings. It's giving out to the surroundings, the product side. So it's called an exothermic reaction. This is the profile. And we have the activation energy, which is the minimum energy required for a chemical reaction to occur. Are we getting it? The major work of a catalyst is to lower the activation energy of a reaction. Do we get that? The major work of a catalyst is to lower the activation energy of a chemical reaction. Now, we want to look at these studies to know the spontaneity of a chemical reaction. What do I mean by spontaneity of a chemical reaction? A reaction that doesn't need any artificial influence. A reaction that will proceed on itself. Are we getting it? So that is what is called a spontaneous chemical reaction. Now, from this energy profile, we know that exothermic reaction, enthalpy is negative, and for endothermic, enthalpy is positive. Let me write another equation so that we know. Okay, let's look at identification of some other parameters. We know that this one is called gives free energy, and this is what? Entropy. So we have a general formula that says this free energy is equals to enthalpy minus T change in entropy. That's what we are going to prove the spontaneity of a chemical reaction. Permit me to rub up this. Then, okay, before I do that, you know that when your G is negative, we call this one what? A spontaneous reaction. When G is positive, we call it what? Non-spontaneous reaction. And when G, which is the gives free energy, is 0, we call it what? The reaction is what? At equilibrium. When the reaction is at equilibrium, G is equals to 0. Delta G is equals to 0. Do you know the meaning of when something is negative? That means the number is less than 1. It's less than 0. Okay, let's check that. Permit me to clean this. When you say G is equals to negative, what we are saying in the table is that G is less than 0. Are we together? Any number less than 0 is negative. Are we together? So when you say G is positive, what we are saying is G is what? Greater than 0. Please let's take note. Now, for this, let's check this. The values for spontaneity of the reaction, since G is equals to delta H minus T delta S entropy. Look at this. When this one is negative, let's say minus 1, and entropy is negative. Let's look at what we can get. And let's say our T is, most of the time T is not so relevant. So let's put T is equals to 1. Let's put those values in. And G will equals to what? Minus 1 minus bracket. The 1 is here, minus 1, which is the